All right, let's get into the functional groups with single and double bond. So we're going to be focusing on our carboxylic acids, amides, and our esters. As you can see, there's definitely some similarities between them. They all have a carbonyl group, okay? And they're all made of a single bond as well. So both these things together, having that carbonyl group and having those single bonds like OH here, NH here, and oxygen and carbon here, are what allow it to have single and double bonds and therefore be distinguished separately from the other group. All right, let's get into the carboxylic acid or the acidic authority. So they're guided by the calculating carboxy kappa, who use their acidic power to have influence over other families. Okay, so the carboxylic acids have many functions. They can act as catalysts. They're part of preservation, of food preservation. They could be vinegars. They're good for the skincare, like salicylic acid for folks with acne. Okay, all those are carboxylic acids. Now, one of the main things that helps distinguish this group is that they contain the functional group COOH. So that means they have their carbonyl. That's where the double bond coming from. Then they have oxygen bonded to a hydrogen. Okay. So that's how you have CO and then OH. There's carbon bonded to this oxygen and then also bonded to this oxygen as well. Okay, so anytime you see that, that's going to help you recognize, hey, there's a carboxylic acid functional group right here. Now, when you're naming carboxylic acids, guess what? It's very similar to how we name hydrocarbons. All we need to do is change that suffix. So we can have our prefix, our root, but our suffix is going to be oic acid. Okay? And sometimes there are common name exceptions, and you might get into those common name exceptions when you go into organic chemistry, the actual course. For us, we're always going to have that oic acid as an ending. So you have your OH group, we can consolidate here. You have your carbonyl. Your carbonyl is going to help you start off the actual numbering of your parent chain, and we'll see those examples next. Okay, so we start off with the prefix, root, and suffix. We know our suffix is going to be oic acid, okay? So what we want to do is first make sure that we can identify that functional group. I see my carbonyl, so that's good in both of these. And I also see my OH group. So I have my COOH. I'm dealing with the carboxylic acid. Now you want to make sure that you can name the longest parent chain. Start with the carbon that already has the carboxylic acid or the carbonyl group on it. So here's our carbonyl group. We're going to start numbering here. 1, 2, 3, and 4. So if I have 4 carbons and they're all single bonds in this long chain, then that's going to be butane. I'm going to take the E and add oic acid. So I can rewrite it as butanoic acid. All right. And that's would be how we consolidate for that. Now let's go ahead and do another one over here. We got to still get our root and our parent chain. Okay. Now, as you can see, we have our carboxylic acid, so we know it's going to end in oic acid. But we also have a halogen here, and we have a benzene ring. So we have to first identify the benzene ring. Now, we know when it's benzene, the root and the suffix are going to combine, and you're just going to have benzene. So if this is carboxylic acid attached, I'll just drop the E, and I'll have benzenoic acid as my ending. All right. Now I have to definitely consolidate my chlorine because I've gotten the ring and I've gotten the carboxylic acid group. So now I have to go ahead and have my chlorine. I want to make sure that I'm numbering my chlorine. And with the haloalkanes or any kind of halogen that's going to be attached to anything, whether it's an alkane, alkene, or alkyne, as you can see, or a benzene like an aromatic compound, we must have that prefix. And that prefix on the root must be, make sure I just remember that prefix on the root must be like chloro or bromo or whatever the halogen is. So this is chloro here. We're going to have chloro. And now we just need a location as well. So we can number it as 1, 2, 3, 4. Remember, we're going to start from the carboxylic acid numbering. Even if we go the other direction, it's still going to be 4. So this will be 4-chlorobenzenoic acid. All right. Okay, let's get into the esters or the elegant envoys. Okay, they're ruled by the charming ester emperor, and their goal is to basically exude elegance and allure through perfumed alliances. Okay, so some of the examples of them will be like banana flavoring, apple flavoring, sometimes wintergreen flavoring as well, and it can also act as a solvent. Okay, so there's plenty of examples of these, all of these functional groups that we've been developing. The difference with esters is that they do have that carbonyl group, they have that oxygen, but the oxygen is not bonded to a hydrogen, it's bonded to another R group, which we know is going to be carbon-carbon and carbon-hydrogen non-polar bond. Okay, so that means you're going to have a functional group that's going to be COOR, or carbon double bonded to oxygen, and also single bonded to this oxygen, which is bonded to an R. Okay, so how do you go about naming your esters? Well, first and foremost, you want to identify the COOR group. That's the main thing. And then you want to basically name like you do any other hydrocarbon, and you're going to change the ending with an O8. So instead of E as an ending, it's going to now be O8. Okay? Also, the R group that's attached to your oxygen, any R group that's attached to your oxygen will become your prefix. Okay, so that's another little difference. You're going to have your prefix, your root, and your suffix, but the prefix here is going to be based on the R group. Your root is going to be based on the carbonyl group. Okay, and so we'll talk about that when we get into the examples next. But as you can see here, we have our carbonyl group here, and it's going to be 2 carbons. So that's going to be our F, right? And so we have ethanoate. Of course, this is like a common name here. And then there is an ethyl group coming off of this oxygen, which is an R group. So we have to put that substituent first. So we have ethyl, ethanoate. Okay, now when you get up to organic chemistry, you're going to see a lot more common names like I've been saying before. And I also just want to remind you that, remember, these are all flashcard moments. So make sure you are stopping yourself and giving yourself a chance to actively practice and try to get this information in your own words. And don't forget here, the suffix does change to that O8. Okay, let's get into some examples. First, let's set up our prefix, our root, and our suffix. We know the suffix is going to be O8. We know the prefix is based on the R group. When you have COOR, the prefix is going to be based on that R group. So we need to definitely identify where the ester portion of these groups are. So of course, I just try to find my carbonyl group. Carbonyl group, carbonyl group. Then I'm going to find my oxygen. Then I'm going to find the R group attached to the oxygen. That's going to help me be able to answer all these questions. And then when it comes to naming, we want to make sure we're going with the longest carbon chain that attaches to that carbonyl group. So here we have carbon 1, 2, and 3. Here we just have carbon 1 and 2. All right. What we do now, we put it all together. So if this is a 3-carbon chain here, but if this is a 3-carbon chain, that means we're going to have propane as our overall longest portion, right? Or as our root. And so we're going to drop the E and we're going to put propanoate. All right, good. We have that portion. Now, the R group is a methyl group, so we have to use that as our prefix. So this is going to be methyl propanoate. Boom. Now let's go on to the next thing. Again, we have our carbonyl group. That's going to be carbon 1 and 2. 2 carbons is going to be our ethane. So I'm just going to write ethane here. And again, I'm only putting ane because these are all alkanes as well. I don't see any excess double bonds inside of this group. I'm going to drop the E, and I'm going to get ethanoate. All right, cool. Now we go ahead and name the R group. That's easy. So now we're going to name the R group. There are 2 carbons here, so that's going to be ethyl. So this is going to be ethyl ethanoate, and that's how you name our esters. Now our final group are the amides. We can call them the nitrogen nobility. They're led by the astute amide dom. And this family loves to create stability and reactivity. They're very resilient, and they're part of a lot of industrial chemicals, lubricants, pharmaceuticals, biological processes. The list goes on and on. So what makes them distinguishable? Well, that's going to be that they contain the RCON group. Okay? So we know the R group. We know the CO is going to be our carbonyl group, and now we have nitrogen. Before we saw oxygen being attached to this carbonyl group, now we see nitrogen being attached. Now, when you have nitrogen, you know it can make 3 bonds. 1 bond is going to carbon. So these could be anything. They could be hydrogens or other R groups as well. Okay, so just keep that in mind. And of course, as you go higher in organic chemistry, you're going to get way more details about how to name these and have a lot more information about where everything goes. But the general consistency is that you're going to basically identify the functional group portion. And then when it comes to naming amides, you want to replace the E or the suffix. So we have a prefix, our root, and our suffix. You want to replace the suffix with the ending amide instead of the E. Okay, so that's what we're mainly going to do. Here's an example, acetamide. Again, we can have ethanamide, but aceta sometimes is what we use for 2 carbon types of molecules in common name. Okay, so you could have ethanamide here. You can identify the group, and then we actually have this carbonyl group being a part of the longest parent chain, and that's going to be at 2 carbons, and that's how they get ethanamide. So again, the ethanamide portion is what's going to allow us to make sure that we distinguish this is an amide group. We're also going to have something like the benzamide, which is going to be the benzene ring, and then the amide attached to that. All right, let's get into some examples. Okay, so we have our prefix, our root, and our suffix. Our suffix is going to end in amide, right? And we also have to make sure that we are going to find our R group, carbonyl group, nitrogen bond to signify that we have an amide functional group. So again, I'm just going to go ahead and find my carbonyl groups, which I see here. I'm going to use my carbonyl groups to help me name my parent chain. So I have 1, 2, 3 carbons here. I have 1, 2, 3, 4 carbons here. And then, of course, I'm going to identify the other portions. So this whole thing will be considered my R group. Okay. This would be considered the nitrogen attachment. So yes, I do have everything I need to say that this is going to be a amide. Same over here. I have my R group. I have my nitrogen attachment. So yes, we're dealing with amides here. Now, next thing I want to do is go ahead and name my parent chain and then just change the ending. So I have 3 carbons here. They're all single bonds here, so it's going to be propane. Okay, and what we're going to do is replace the E. So propanamide. Okay, that is going to be the name for this. There are no excess things to say for the R group. It's already a part of the propane. Now with this one, we have our NH group here. We have our carbonyl. We know we have 4 carbons, so we're going to be dealing with butane. But we also have this halogen substituent as well. So we have to make sure that we are trying to use the prefix for bromo, which is going to allow us for the halogen bromine, and that's what we're going to use. And we also need the location. Okay, so I have my butane. I'm going to remove this, and I'm going to replace it with amide. So this is going to be butanamide. Okay. Now, with my actual R group over here, I have to make sure that I'm actually consolidating any naming for that too. And since I have a bromine, it's on carbon 2, I have to say 2-bromo butanamide, and that will be my final answer. So again, this is kind of like more work because you're layering in multiple rules, but that's sometimes going to be the name of the game. And once you get into chemistry, you're going to be layering all these rules as well. So we have officially made it through all of our different families. Okay, so you know it's time for review, right?